All right, so here is your first work order here, and it says the manager has changed things. Program 11 through 13 work. Now program 9 is needed, but it causes an alarm. So always like I say, take work orders with a grain of salt. Just because somebody has changed something might or might not have anything to do with it, but it's good information, good to know. And so we're looking at the problem with program 9. Now, looking at this, and when I came in, power was off. I turned power on, but even before um, I turned power back on, I released the emergency stop. I noticed something, and it's a visual. And so I'm gonna ask you to look around at the tank. I'm gonna move this out of your way because it's dead. There's nothing to see on this panel or this panel with emergency stop pushed in. There should be something that um, sticks out at you. So let's see if you know the answer to that. All right, what stuck out at me was this tank level seemed a little bit high, and I know that because I watched the video prior to this. I saw where the tank level would fall under normal conditions, and it was just a little bit lower than this. Now, the first question we've got obviously is, are we using program 9? So I'm going to go in and I'm going to open my cabinet. I'm going to hook up my laptop, and I'm going to say PLC, go online. And sure enough, up here it tells me we're looking at program 9. So it says the tank fills with 40% liquid from intake 1, then 85 from intake 2. So we're going to get 40% from intake 1, another 45 to get us to 85 from intake 2. Then we're going to heat it up to 70 degrees. Agitator is going to go off for 5 seconds, then on for 7. It's going to repeat that 3 times. Then it's going to rest for 5 seconds, then it's pumped out. Well, the first thing I'm kind of curious about is what is causing my alarm light. And there are 4 things that could potentially cause this alarm light here. Alarm temperature, which could go down, but alarm float, which we are seeing is on, agitator overload, and pump overload. Now, this last bit is just a latch. In other words, anytime the alarm goes off, we're going to latch the alarm light because temperature, for instance, can go down and we may have a temperature issue and have an alarm. And all that would happen is if we did have an alarm and this temperature went off, it would stop it, then it would cool down, and then it would heat it back up, and it would stop it, and it would cool down. So by doing this, it sets that alarm status as permanent until we press the reset. So just as we suspected, we have an alarm float issue. And if you remember, this tank is designed to have a 0% float switch, a 40% float switch, an 85% float switch, and a 90. Well, we hit the 90. So that is our problem, it seems. So let me ask you, what would be the benefit of going and looking at the input side of my PLC card? Why would I want to go look at my inputs on my PLC card? All right, so the reason I would want to go to the input side of my PLC card is I want to know if the PLC is seeing the status of the float switches. And when I look, I've got a low float, which is 8, which means it would be on as soon as the tank gets any amount of fluid. I've got a 40 float that would be on once it hit 40%, and 80 that would be on when it hit 85 that would be on when it hit 85, and an alarm if it exceeded and got to 90. Well, I'm seeing the low float on, 8 is on. I'm not seeing 9 on. I am seeing 10 on, and I am seeing 11. So the issue comes into play with the fact that my level 9 float switch is not on. And it's got to be, or it needs to be, because if the 0 is on, if we're all the way up here and we're turning on the 90, then we'd have to have on the 85, we'd have to have on the 40, and we'd have to have on the low. So, with that said, with us now absolutely knowing we're not getting this, what might be our next step? All right, if you answered, go to the float switches and see if they're closing. And if we need to know exactly how our float switches work, we can come to, and it's in one of these. I always have a hard time remembering which one. It's the one with the little drawings on the outside of it. And I think it's down here in the, nope, not in the output. I always skip around it. It might be in the input. Oh, I'm on the input, so it's not that one. Power circuit. Nope, it's the more square one. Yeah, I probably skipped right over. Here it is. All right, so if you look, we've got 1, 3, and 5 daisy chains. So that's a voltage level of 24 volts that's coming into 1 and coming to 3 and coming to 5. So it stays 24 volts all the time. So what should happen is when the switches are closed, we should measure 24 volts on both sides of the switches because they should be closed. So I need a place to put a ground. So I'm going to leave this up here and I'm going to come in here. I'm going to borrow a place to put a ground here. So I'm going to take out my meter. I'm going to set it for voltage. And I'm going to come to pin 1 because we know we should have 24 volts across every single terminal. And it says negative is a reference point. So let's do that. So we'll go to negative on our 24 volt supply. There we go. So I was using ground, using the wrong minus there. So pin 1 shows 24 volts. That's our 0. That's our 0. So we know this switch is closing. It's 24 volts. It's on pin 1. It's on pin 2. Well, this is our 40. It's got 24 volts on the input side and nothing on the output side. And let's keep walking down. 24. This is our 85. And this is our 90. 90 is good. So sure enough, the reason we went to our input cabinet is we wanted to see if we were getting it and maybe the PLC wasn't acting on it. Now we went over here to see if we're getting a closed switch. Well, we are not. So what might be the best next step? So if you answered lock out the cabinet, we're going to verify it's dead. And notice I've already removed my meter leads and said, let's inspect the pump, or excuse me, not the pump, but the float switches. So anytime you have an opportunity to inspect something, you would want to do that ahead of replacing it because obviously if it's cheaper to inspect something than it is replace it. So I'm going to inspect it. And it says one of the float contacts didn't close correctly. So obviously if it didn't, we're going to have to replace it. So that's what we're going to do. Now we're going to remove our lock, turn it on, we're going to bring power back, we're going to drain our tank, and we're going to cycle our system and see. So we're in a remote, so we're going to have to use our remote switch. Oh, we got to reset our alarm first. Minor details, huh? There we go. Now we're ready. So remember, we know it's going to do the 40% to 85%. And then we're going to have some degree of heating and agitating, heating and agitating. And the other thing we can do is just for grins and giggles, look and see if our float switch closed. Yep, 8, 9, and 10 closed, and now we're cycling. Not worried about 11 coming on because we know it's our fault, so we made it. Notice our fluid level is lower. So it looks very much like we got it fixed, but we're going to wait till the very end and see if we're right. So agitate, heat, rest, and pump. Let's see if that's what's going to happen. We'll agitate some more. Rest some more. I think we agitate one more time, and I think and we should rest and drain and get our now should be done. Drain it. And we're waiting on a report that says we're good. Pass. So think about what we did there. Very first thing we did was we read our work order and it said the manager changed a bunch of stuff, or at least changed something. Well, it didn't have anything to do with the manager specifically changing anything. It had to do with the fact that we had a float switch that wasn't functional there. And so the very first thing we noticed was a high level value in our tank. So then we went and looked at our IO. We saw the fact that, yep, and we saw our alarm going off because of that switch not turning on. Then we went to our IO and saw there was no readout of the indicator showing that that switch had closed and the PLC was just not acting on it. So then we went up to our float switches and we verified that float switch wasn't closing. We took our float switches out, we inspected them, found the faulty float switch, and we replaced it. And the rest, they say, is history.